Let's explore polygons and see what their interior angles add up to. First of all, I'd like to help you develop a general formula for this by looking at polygons. We all know that the smallest polygon is a triangle, and every triangle has 3 angles that add up to 180 degrees altogether. Well, a triangle has 3 sides and adds up to 180 degrees. That's the angle sum. What happens with a bigger figure? Well, let's say we've got a parallelogram or some other kind of quadrilateral. If we draw in as many diagonals as we can from one vertex, in this case that's only one diagonal, it divides the parallelogram into 2 triangles. So a 4-sided figure can be divided into 2 triangles. Each of those triangles is 180 degrees. So we take the number of triangles and multiply by 180 degrees to get the total, and that's 360 degrees for 4-sided figures. Let's check a trapezoid so that you don't think it's just true for parallelograms. If I use this vertex, I can draw one diagonal right there. Okay, the 2 triangles don't have to be the same. That's not the point. Every triangle has angles that add up to 180 degrees, and there are 2 triangles in a trapezoid and every other 4-sided figure. Okay, let's look at pentagons. So we've got 5 sides. That's like a house, right? So if I choose this vertex and I start drawing diagonals, there's one, there's another. That's all I can draw from that vertex. I see 3 triangles, right? So the total is going to be 3 times 180, and that is 540. So the sum of all the interior angles of a pentagon is 540 degrees. Okay? Let's just try one more, a hexagon. Okay, now it doesn't have to be a regular hexagon. Any hexagon is going to have the same angle total. So here's my hexagon. I pick one vertex. How about this one? And from it, I can draw 1 diagonal, 2 diagonals, and 3 diagonals. How many triangles do you see there? Looks like 4. So the angle total is 4 times 180, and that is 720 degrees. Okay, so let's go back to the triangle example. 3 sides. Well, how many triangles are inside a triangle? Just 1, right? There's my pattern. Now let's look at that pattern and see if we can generalize it. That means, what about n sides? Because I know there's going to be some sort of big theoretical polygon with 100 sides, and I don't want to have to do this chart all the way to 100, right? I should be able to figure out a formula. So let's look at what happened every time. We had a number of sides. What's the pattern from the number of sides to the number of triangles inside? What kind of math is going on here? Well, it looks like every time the number of triangles is 2 less than the number of sides. See that? 2 less than 4, 2 less than 5, 2 less than 6. So I need to write an expression that means 2 less than n. Whenever you hear less than the variable, that goes after it, just like that. So n minus 2 is an expression for the number of triangles inside of an n-sided polygon. Okay? Then what did we do? We took the number of triangles and multiplied it by 180 degrees, because there's 180 degrees in every triangle. So in our formula, we need to use n minus 2 for the number of triangles and multiply it by 180. And that is our general formula for the angle total. So we would write it n minus 2 times 180 equals the interior angle sum of every polygon. Let's look into this a little bit further. What about individual angles? Well, we can only figure out the measures of individual angles when they're all the same, and we call that a regular polygon. So for example, a square is a regular polygon. All the sides are the same length as each other, and that's what those marks mean, and all the angles are the same as each other. That's what a regular polygon means, okay? In a regular polygon, we start with the angle sum that we figured out on the previous slide. So for four-sided figures, that was 360. We divide by the number of angles, and that's the same as the number of sides. In this case, there are 4. And so each angle has to be 90 degrees. And that's true for squares, right? They're all right angles. That's what makes it a rectangle and a square. Okay, but what about some other regular polygon, like an equilateral triangle, for example? Okay, if all the sides are the same length, then all the angles have to be the same also. We know the angle sum for triangles is 180 degrees, and there are 3 angles, 1, 2, 3, so we divide by 3 and find out that each angle in an equilateral triangle must be 60 degrees. And it looks just like that. So that's how you find the individual angles of regular polygons.